Ladies and gentlemen, my name is Guilherme and welcome to another video, and this is a tutorial video on how to get started using Cave Engine 1.1. So the engine is finally out if you are following here this channel, and you can actually purchase it on itch.io or become a patron and get access to it as well. And by the way, until the end of this year, 2024, the engine is 40% off on itch.io, so I highly recommend you checking it there, because that way you get lifetime access to the engine. You don't need to pay anything else, and you can use it as you wish. So it's a very great deal. People are taking this opportunity to acquire Cave, so I thank you so much for the support also. So without enough talk, let's go ahead and jump to this video. And the idea here is to get you a solid foundation on how to start making your own games using Cave. So first things first, I want to just remember you that we do have a demo project, and this project will be very important. In the last video I talked a lot about it, but this is just a reminder. You can download the demo folder, the demo project, in the same directory that you find the engine itself, and then you can click here browse project. You need to extract the demo project, and if you click browse project, you'll be able to find the project in your disk, so you can open it. Okay, and once you have it, by the way, make sure you extract this in a folder with no special character. This is a no limitation from Cave, so make sure there's no special characters. Okay, but once you open it, you'll be able to see a lot of things. And if it's your first time using the engine, I highly recommend that you navigate through this demo project. There's a tutorial documentation file here. If you click here once, you'll be able to find here in the right corner, welcome to the Cave Engine guide. So you understand the basics of the editor, the project, the assets, the scene, entity, components, the 3D view controls. So we have everything very well explained here, with the shortcuts and everything you need to know, really, in order to understand how to use Cave. So this is very good, very important. And the reason why I moved this to text here in the demo project is because it's very easy for you to go back and look, so you don't need to watch a video to remember a shortcut or something like that. So the entire documentation on how to get started your first minutes with Cave is probably here in this tutorial, so I highly recommend that you see it. And by the way, this tutorial is new. I just added before recording this video, so if you downloaded this demo project, I mean yesterday or something like that, make sure you download it again, so you can see this tutorial. Okay, and after that, you can navigate through the scene. You can go ahead and open the readmes here, that you find a bunch of good stuff. For example, the exploration tips here. And then if you click here, you have a first-person demo with, of course, first-person controller. I've showed that in the last video, but this is very important for you to understand, because here you'll be able to expand stuff, you'll be able to click stuff, see how the script looks like, edit the script if you want. So you have a lot of options here. And of course, you have the README everywhere, with documentation to actually explain to you how everything works, including the common here. People tend to ignore the common in the demo. Don't ignore this, because we do have readmes here. And for example, the materials, let me go ahead and open the test material. There's a readme here that explains exactly how the material works. So it's very good for you to understand, to read everything. Okay, so this is a great source of inspiration for you to study and get started with Cave. And for this video in particular, I will assume that you already understand this, that you downloaded the demo, and then you read the tutorial, and then you read the readmes, you play it, all the demos, because again, if you go to the demo folders, you have first person, you have menus demo, you have particles demo, save and load, third person, top down, vehicle demo. So there's a lot of stuff going on here for you to open, expand the scene, press F5 to play, and then you can see how everything is working. So this is a top down demo. Of course it is, as you can see here, and you can explore how everything works. Okay, so now We will jump to the actual tutorial part of this video, finally, of course, but I will assume that you already have this knowledge, that you already have this basics, okay? And what we are going to do is to basically recreate the third person demo for this project, but I will show you how to import a character, a skeletal animation character. I will show you how to write the logic using Python to it, how to set up stubs, how to edit using an external editor, and also how to import other models from different sources for you to build your game. So this will be very nice. I will close here the project. I don't want to save, and then I will open Cave again, and we will create a new project. So I will click here, new project. Now type live YouTube demo, something like that. If I don't pick a path, it will save this at app data directory on my computer. For me, it's okay. I will click here, create project, and boom, it created the project. We are ready to get started. I can press F5 and play the game. There's nothing going on here, of course. So let's go ahead and start importing stuff. And the absolute very first thing that we want to do here is to import a character for us to start writing the logic for it, of course. So I do have this proto character. This character is also in the demo, and it was made by an awesome artist. If you look at the demo project and also in the description, you will find the credits for this specific 3D model here. This artist is way better than me, of course, and the animations here are from Mixamo, and I will provide this character for you to download as an FBX file for you to follow along with this tutorial. Because of course, if this is your first time using Cave, I want you to be able to have a smooth experience following this tutorial. So it's important for you to have the same character here with the same animation, so you don't need to worry about creating new ones and so on. Of course, if you have experience and after this tutorial, you can go ahead and create your own character. And follow along with this again, it will be fine, okay? But for this tutorial, I will be providing the link to download this specific model here and the animations that we are going to be using in this tutorial, okay? And taking advantage of that, I'm here with the character open in Blender. You can see that there is a skeleton here. This skeleton is from Mixamo, so I've uploaded this character into mixamo.com and downloaded some motion capture animation. So this rig is from Mixamo, and the animations that you will find to download are from Mixamo as well. There is one thing that is very important for you to know before importing animated characters into Cave, is Cave have a single limitation at the moment, that an animated character or an animated mesh in general can only have one material. So if you go to the proto mesh here, this mesh, of course, you will see that the entire object is a single material. You can see here. So if you have multiple materials in your model, it will not gonna work very well with animations in Cave. If it's a static objects like a building, a car, a prop, or whatever, it's fine, no problem. But if this object does have animation in it, then you have to bake this into a single material. So if you're using Maya, Blender, or whatever, you can look up online how to bake this into a single material. It's not very hard, and this is a known limitation just for performance and some other reasons, okay? So this is the only thing that you need to know before importing a character into Cave. It needs to have a single material, okay? Okay, so with that out of our ways, let's close Blender and open Cave again, and I will import this character. So I have a folder here with a bunch of animations. Of course, I will be providing the animations for you that are necessary to properly create this setup that we are going to do here. But I will for now import some here to our project. And I will import the idle animation, the walking animation, the run animation, and probably the falling animation. By the way, as I said, I will be providing these animations, and I will probably rename them to make this a bit easier for you to understand. So if the names are different, don't worry about that, okay? So I'm selecting all these animations here, and I will drag and drop. Actually, let me just drag and drop the unarmed idle, the idle first, so we can test to see if everything is alright. So click, drag and drop, and you can see that Cave is already prompting us to oops, I canceled the importing. Let me import this again. Here you go. It's already prompting us to import the assets. it is asking if I want to create a subfolder. If I enable this, it will create a folder here with the name of my FBX file, and it will put all the assets here inside this folder. And I want, in this case, to have this open. So I'll just expand here the animation, and I will change the animation name. I'll call P, that stands from player, idle. I like to name animations like this, but of course you can name as you want. You can put like player idle, you can put white spaces, you can put underline, it's fine. But remember the name, because we will be using this when we are writing the code for our character, okay? So this is the idle animation. I will expand this template and I'll call this proto. Actually, I'm not gonna import a template. The entity template is pretty much like this FBX file. Of course, there's a scene in it with the compositions of your objects and all that. It's in Blender or 3D Max or wherever. And this entity template tries to replicate this composition. So if you're importing an entire scene, an entire world to your game, the entity template will have a replication, an attempt at least, to replicate this world, okay? In this case, I just want the character, the animations, I don't want the template, it's fine. So I expand the mesh, I'll call it proto mesh. Proto is the name of the character, stands for prototype, of course. I do have textures here, and I'm not gonna mess around with them, it's good. I do have the armature, I'll call it proto armature. And of course I have my material, and I'll call this proto math with a white space instead of an underline, just make things consistent. And of course I know this is not consistent with the animation name. I don't know why, but it's been years since I named my animations like that, and well, whatever. I'll click here to import asset, and you can see that I do have a folder as we enable this with the name of the FBX. Of course I will rename this to proto. And if I double click it, you see every asset that we had. If I click here in a proto mesh, you will see here that it is currently not in a good position. And if I move this to the world, it is of course not animated. There's a way to make this easier for us. I'll click here in this mesh. I've deleted this, so I'll click the mesh. And you can identify a mesh in Cave because the meshes do have this gray bar here below them. So this is an easy way for you to identify a mesh. And if you go to the scene, it does have a blue bar here for you to understand. So it's easy. If I click Ons and then go to Hints, I will be able to select an armature and animation for Cave Engine to initialize this mesh with this. So when I drag and drop this to a scene, it will initialize this mesh using this animation and armature. By the way, this is not a rule. This is just a hint for Cave to initialize the mesh for you, okay? Very important. So I will select the proto armature and the P idle, which is the idle animation. And then if I drag and drop this to the scene, you'll be able to see that this is already working. It is initialized properly with the animation. Very nice. So let me delete these lamps here. Also start to play around a bit with the world, and I'll click here in the background just to edit the scene. You can also go ahead and click here to edit the scene, or click here. So there's a lot of options for you to edit the scene. And then if I click here to expand the sun, I'll click here to expand the shadows, and in the area for the shadows I will reduce the area a lot because I want to have crisp shadows. And Cave Engine does have cascade shadow maps, so even if the area is very small, you can see that everything will still have shadows. Let me actually disable the influence, and then later on we'll be able to adjust this a little bit better. I want to do some skybox and all that in this video actually, so stay tuned for that. It will be very important. And then I'll also change the angle of the sun, just for us to see everything a little bit better. Good, so this is better, at least for now. Let's go back and keep editing this player. If you see here, it created for us, when I dragged and dropped this mesh, an entity, and this entity does have a transform, as we can see here, and it does have the mesh component that do have the mesh and the material used by this mesh, and last but not least, it does have an animation component. And the reason why it does have this animation component is because we defined it in the hints here. So this is why it created for us the animation component. If there was no hints for animation, it's not going to create the animation component for us. And by the way, I can change this later on. I can delete this animation component here individually, and it will not going to influence anything. Okay, so now we talked already a lot. Let's go ahead and finish importing our animations. So I will this time import the walking animation, but I'll also import the standard run and maybe the falling animation. So let's drag and drop those three animations. You can see that I have a prompt as before, but this time I do have three options here. Oops, and I closed one. Let me cancel this and do it again. It's funny because as I explained, I'm looking at my other monitor to see if everything is alright and if you guys are seeing everything. So sometimes I click accidentally out. And many people ask, by the way, why I do have two cursors. You're seeing two cursors here. It's just an OBS thing because I make it to always enable the cursor to be visible. But if I zoom with the camera, it gets confused. So it starts showing two cursors. But trust me, there's only one. Anyways, so in the standard run, what I would do is I don't want this time to create a subfolder because I want to put the animations right here. And I will disable everything except the animation. And the animation I'll rename to P, that stands from player or proto, run. The walking animation will be the same. I'll disable everything. And I'll rename the animation to P walk. And the falling animation, once again, same thing. Disable everything, P fall. And with all that out of the way, I'll click import assets, and you can see that I do have more animations here. Let me save real quick by pressing Ctrl S to save my project. It will save all the new files that I dropped, imported or changed. And of course, we can preview this animation to see if they are imported correctly by one very easy way to do this preview is clicking here, this character that does have the animation here, and I can simply double click the animation and it will replace this animation here with the animation we clicked. So if I click P run, you can see it is now running. P walk and fall. This is a terrible falling animation. We don't want this, but it is here. Let me actually go ahead and import another fall. This is a better one. Let me go ahead and delete the other one. By the way, now that I'm here, let me actually explain something to you. If you will notice sometimes here in this video that the performance will really be bad. Can you see here right now? Why? It's an optimization here that Cave have to save your computer from running 100% all the time. If I am not focusing on the editor, it will not gonna run the editor at like its highest speed. It will simply cut frames, skip frames on purpose just to make your computer not cry. And this is especially helpful if you are using a laptop because of course you want to save energy, to save your battery. So if you're doing something else, it will start to skip frames. So this is very good. So if you see this happening, it's not Cave fault, it's just because I'm doing some adjustments here in another monitor and you're not seeing it. Okay. Anyways, so you can preview here the animation, the walk, the idle, the run, and all that. And this is actually a great opportunity to show one important feature that Cave does have regarding animation. It does have root motion, and it's very easy to have root motion in Cave. This animation, of course, is not root motion ready, because you can see it is already running in place. So if you have an animation in games, it's very common that this running animation, it will actually go forward and then go back. And this is an animation that needs root motion. If that's the case, I will simulate this, how you will be able to extract the root motion. I can go here in root motion. I can select a channel, which is a bone name for my root motion. In case of Mixamo, it's the hips. And if I select this, I will be able to click here to enable root motion in each individual axis. You can see there's no changes because it is already in place. But if I click here in the y-axis, you can see that it is no longer moving up and down anymore because I'm extracting this root motion from this bone, and it will be available for you as in Python. Okay, so the animation component does have a Python method to get the root motion currently being executed. So this is very good, very handy, and it's good to know for you if you're using Cave, of course. Another thing that is very good in Cave is we do have callbacks, so we can create a script here that gets executed every time the animation starts, every time the animation ends, and on a single specific frame. So for example, if I want to make a footstep here, I can expand this animation preview, I can pause the execution of the animation, and then I can, well, this is a place where I want to put a footstep, so it's frame 7.35. I'll just hold Ctrl 7.35, and then I click here at the code, and I'll play the sound. Play sound here. So every time the animation goes to this frame, it will execute this code. And by the way, this is somehow how to play sound in Cave. So this is the sound name, and I can get this and do sound.volume to do something, whatever. So this is a handle for the sound. So this is just an example. Of course, we don't need to do this. We don't have sounds here in this video in particular, but this is for you to know that it's very easy to do this kind of things in Cave. Okay, let's go back to the idle. We talked a lot, so it's time to actually get things done. And the next thing that I would do here actually is to organize this a little bit better. I'll actually rename this folder to player instead of proto. And then inside this folder, I'll right click, asset settings, and I'll click a group asset, and it will automatically get all the assets by the type of the asset, and it will put them into a folder. Okay, I renamed this texture here. I actually moved this texture to inside the material folder, and I'll probably get this right click and dissolve the mesh folder so we can see the mesh here. And I'll actually do the same thing to the material so we can see the material and the textures here. So it's very easy to organize stuff in Cave, as you can, as you notice probably. Very easy to do this. Let me actually dissolve the armature. It's fine to have the armature here, but the animations, I want them here organized. So let's go ahead and start writing some logic for the game, because it's at the moment very boring. There's nothing going on. And I want to press play and see something going on, be able to move around and so on. So let's do this right now. First thing I will do is to create, believe it or not, another entity here. So I will press Shift A, go ahead and create a new empty, which is an entity with a transform. And I'll call this empty here player. And then I'll select the proto mesh, which is of course, the character, and I'll make this a child of the player by clicking and dragging to inside the player. So you can see I have the player and I have the proto mesh. You can see that the proto mesh is a bit offset from the player, and I don't want this. So I will press Alt W to reset the position of this. Another way to do this is to simply go to the transform, and in the position I will set everything to 0, 0, 0. Same, but of course Alt W, it's way easier, right? And it works with Alt I, Alt R, and all that. It's very easy. This is important because we want to control the player, this parent object, not the proto mesh itself. Because sometimes the mesh will be looking at a different direction as the player is. Okay, kind of hard to explain, but easy to see in practice. Let's select the player and add a component here for the physics. Because if I press 3, it's the number 3 that is right above the W key in your keyboard. You see that it is enabling the physics visualization. By the way, you can simply go here in the viewport settings, and you can have here draw debug physics, and you can see there's a shortcut for it, which is 3. So this is why I said. So if I click here, you can see that the ground does have a physics in the world, and this cube also have a physics, but the player does not have anything. So I will select again the player, not the proto mesh, and I will go ahead here in this properties tab, right click, and I'll add a physics, character physics. So you can see here that I do have a huge ball here representing a character, but of course the position is very wrong. What I will do is in the offset, in the y-axis, I will move this 1 meter up, and I'll actually hold Control here and click to type manually 1. So it's a little bit better. Maybe the height, I'll actually put 1.8 in height, and then of course I need to compensate here, so 0.9. And I know these numbers by hand because I'm used to do this, but of course you can adjust, you can fine tune it as you wish here. It's not a problem, okay? And then radius, I reduce radius because the character is a bit skinny. So this is the correct radius for it. Very nice. And one thing that is important to understand is that this arrow for the character here represents the forward, the front side of the character component, okay? So it's important that the proto mesh is facing the same direction as this arrow, okay? If it's not, you can simply select the proto mesh itself and rotate it. Use Ctrl to rotate using snapping, so it always goes 90 degrees. Let me press Alt I to reset this. Good. I will press 3 to disable the physics again, and the character physics is already adjusted and ready for us to move on. What I will do now is create a camera. So I will go to the player, I'll right click here, add the children, and I'll add a camera. Great, so we have a camera here. If I want to see the preview, what this camera is seeing, I can simply go ahead here with my camera selected to the camera component, and here below I have a preview. I can expand, and this is what my camera is seeing. Of course, if I move up, I move back, and I need to rotate this 90 degrees in this y-axis. So I'll go to the transform, y-axis, I'll double click and type 180. It's not 90, sorry, it's 180 degrees. And I'll move it a little bit back, maybe a little bit up. Yeah, this is enough for us to have the preview, okay? And of course, if I play the game, you can see that it is in the back. So the next thing that I will do here is to create a camera controller, a third-person camera component. And in Cave, this is built in. So all you have to do is to go to the camera again, right-click, camera controller, third-person controller. By the way, in the sample project, you have a more up-to-date script for first-person camera. This first-person camera is deprecated, so if you're making a first-person game, go ahead and make sure you follow the example in the sample project that Cave have, okay? But if you're creating a third-person or a top-down game, those cameras are good to go. So click here, third-person camera. You can see that we do have some new icons here. Let me delete and open it again so you can see them appearing. And what is this icon? Well, this ball here is basically the how can I explain this? The radius of this camera, because of course we don't want the camera to have 0 radius. Otherwise, if the player is behind like a grid, it will constantly be the camera will constantly be going forward and backwards for this grid, like let's say a cell, a prison cell. So this is why we define a radius here. Very important, okay? And this is related to the camera collision. If you expand this, you have the radius and you can change it. I'll leave it at 0.3, which is the default. It's fine for us. And the other thing that I'll do is change the head offset. The head offset is, well, if the camera is colliding with something, it will move forward. But it will move forward to where? Because right now it will move to the character's butt. And this is not exactly very good, nor very pleasing. So what I can do is go to the head offset and move it up. And maybe a bit to the side. So if the camera collides to something, it will move to this position here, not the butt of the character. Good. So if I press play game, you can see that I can already move the object and the camera collides very well. It is colliding with the ground, but you have to trust me a little bit on this one. It is also colliding with the wall. But for us to see this, it's important that we have the logic created for us. So let's go ahead and create this script. It's very important. Let's create the script to move this character around. So let me save this, and I right click here, and I'll go ahead and create a new asset. I'm here in the player folder, new asset, and I'll call Python script. Also, there's another way to create this. Let me go ahead and show you. I'll click here in the player. If it's a new script and I want to create a component, I'll click here in the player because the player will have the logic, and I'll right click here, create a new component, logic, Python component. It's not a Python code, it's a Python component. And I'll click here to create a new script. And it will ask me for a component name. I'll call it player controller. Create script. You can see that it created the script here. There's a component and the start, update, and end method that we expect. Okay, oops, not a for. And it also created here a player controller script in the folder that we are currently open. But I'm not going to edit this script right here. So click here to stop editing it, or you can simply close here the text editor, but I'll stop it here. What I will do is I will save this with Ctrl S, and then I will open this in an external editor because I want to show you how this works. Of course, if you want, you can double click it here and edit the script over here. It's fine. Not a problem. If you don't have an external editor, if you're following along with this tutorial and and this is your absolute first time using a game engine or whatever, or programming, and you don't have, you can edit here, it's fine. But of course, if you're used to an external editor, you can do it. I'll save this and I'll go ahead here in File and I'll click Open Project in Explorer. And it will open for me the folder where I have my project in my computer. So I'll right click here and open Visual Studio Code. Of course, it's in Portuguese in my computer, but in yours will be in English or whatever, your language. And if you don't have Visual Studio Code installed, of course, you're not going to be able to see this here. So again, this is a way for you to open the script in your preferred text editor. And if you're using Visual Studio Code, which I recommend, you see that it is very easy to integrate with Cave. So click here, and then I can already close this because Visual Studio Code is already opened. As you can see here, very simple, very straightforward. Here you go. And I can see here inside the source folder, which is of course the source of my game, I can have the content. And the content is already familiar for us because we can see here content. So to find the script, I have to go to content, then player, and then player controller. So let's try to do this. Content, then player controller. You can see that I do have two scripts, two files. One is the .asset file, which is a Cave specific thing, and one is the .py file, which is what we want, the Python script. By the way, do not move or rename, delete, or add objects, files or folders here in Visual Studio. This will not going to work with Cave. If you want to change the name or anything like that, you need to do this in Cave, not in Visual Studio Code, okay? Otherwise, Cave will get very confused. It will not going to update correctly, so don't do this. We have here the script. And what is nice about using Visual Studio Code to make this is that you can have autocomplete and hints in Cave. So if you have, of course, in your Visual Studio installation, the Python extensions, because if you don't have Python extensions here, it will not going to work. But if you have the Python extensions, it will automatically recognize Cave. So if I, for example, mouse over the component here, you can see base class for all Cave engine components, all methods and variables available here are also available for you to use in your own custom Python component. And the scene here, same thing. You can see there is a documentation explaining what is the scene. And if I start typing stuff, for example, scene dot, you can see all the functions here. Everything that the scene contains, which is very good. So let's try to click a random thing here, add the bug cube, and now click here. You can see the parameters that it takes. So this is very handy, very easy for you to program in Cave. And if you are curious about how this works, it's because Cave creates for you this typings folder here. This is purely for the API reference. And this is also good for you to navigate and understand the API that Cave have for you regarding Python. So if I expand this, there's a Cave folder, and inside there's this init folder. And this is the entire Python API that Cave have. And most functions here even have comments here explaining how they work. You have all the classes. Let me expand here to something else. you have the scene class, and you have the documentation, you have all the variables that the scene have with comments, and you have all the functions and the return types and all that. So this is a good way to study the Python scripting for the engine, very good. But of course, if you want more details, if you want to understand it a little bit better, what you can do is go ahead here in Cave, help, and then click here Cave Engine Python API, and if you click here, it will open a web page in your browser with the documentation. Alternatively, you can also open the engine in Explorer, in File, open Engine in Explorer, not the project, the engine itself. And my installation here have a bunch of debug stuff, but your installation will probably have this Cave Engine Python API.html, and you can drag and drop this to your browser, for example. Let me do this real quick. And you can see the API reference. And this is also a good way to study the API, to understand, because this is a more humane way to do it. You can see this is a very programmer, hard to find. There's no line breaking, so you have to read everything. You have to scroll right. It's good. I really like this way, to be honest. But sometimes you want to do this to read everything in a more humane thing, and it is here. So very good. And I also recommend that you open this before continuing with this tutorial and read. I will do some recommendation. I recommend that you go ahead here and read the scene. So click here in the scene and let's read this. And then go ahead to the component and the entity. The order is, it doesn't matter. You can start with the component, you can start with the scene, you can start with the entity, but it's important that you read what is the scene, what is the component, and what is an entity, because it is very well explained here. And the functions here, they are also very well explained. So what is the update function of the component? It's called every frame if the scene is not paused. Of course, the paused update is called every frame if the scene is paused. So there are alternatives. The first update, there's an explanation for this. The start, there's an explanation, and also the end, and all the other functions here. So I really recommend that you take some time to read the component, the entity, and I mean at least the header of the entity and the entity class. You don't need to read all the functions and all that. It's good. It's very quick. You can see here there's not a lot. So you can get an idea, but at least the header I recommend you reading, and the scene to finish things up. By the way, I've showed this in the last video, but just as a reminder, you can search here for stuff, for example, entity, and you can see a bunch of stuff. You can click and it will go to the place that you want. So very easy to understand. You can expand this here in the left to see everything in the API. So yes, very good here for you to write code. Perfect. Let's go back and finally make this character walk, because I know you all want this to happen. We want to have this character walking, right? So I'll be very straightforward here, and I'll be explaining a little bit. Of course, I'll be explaining a lot what I'm doing. Basically, for this character to walk, we'll split this into two different parts. The first part is to make the character move, actually. So the script is in the player, remember, not in the proto-mesh, is in the player, and we want to make it go forward, backwards, left and right, and maybe even jump as we press a button. So this is the first part, and I'll call this part movement. And the second part is the animation. In other words, I want to basically run a specific animation to the mesh, to the proto-mesh here, based on what the character is doing. If it's idling, it will run the idle animation. If it is walking or running, it will run the appropriate animation. And of course, if it is falling, it will run the appropriate animation. So this is the second step. So let's focus on the first part, which is, of course, make this character walk. And for this, I will have to get the character component, because if you remember, we added here a character physics. And this is what we are going to be using to move it. So in my player controller, in the start method, I will create a function, actually a variable called character, to store the character component. And I will also even hint to Python with this thing here, cave.character component. that this variable here is a character component class. And of course we need to get it. By the way, I highly recommend to have the basics of Python, because I'm not, as you can see, I'm not going to explain what is self. For example, this is a Python thing. This is not a Cave Engine thing. And what is this? This is a type hint in Python. It's completely optional, by the way. It just allows the, if you type something, let me just. The reason why Visual Studio is showing me collided with and all that is because I've created this hint for Visual Studio. So this is a Python thing. This is not a Cave Engine thing, and I'm not going to be explaining in details this Python specific stuff. Okay. Anyways, so let's continue. I'll get the character here by using self.entity.get, and it will receive the component name as a string. In my case, it's character. By the way, you can call character component, you can type the component, but since most components will end with component, Cave allows you to omit the component from the name. So you can just get the character, and Cave will understand that you are talking about the character component. So this is easy, okay? Very simple. And then once I have this character, what I can do to move it is just to set the walk direction. But how to set the walk direction? It needs to be based if I'm moving or not, right? Very important. So what I would do here is I'll create the x-axis, x speed actually, and the z speed, which is the forward, sideways, or front or back. And I'll use the x and z to basically set a walk direction. What do I mean about that? I'll create a cave.vector3, which is of course a 3D vector, with x 0 here in the y-axis, because y is up in Cave, and z, which is front. And I'll use this direction to set something called character direction. So I'll get the character component, and I'll type set walk direction, and it will be this direction here. And last but not least, I need to multiply this by the delta time. So in Cave, you can get the delta time by simply typing cave.get delta time. If you're not familiar with delta time, don't worry about it much, but I recommend you Googling what is a delta time later, or if you want, I can make a video about it, but there's a lot of resources on it, and it's the same in every single game engine. Anyways, so I'm setting this direction here to the character, and if I start the game, you will see the most boring thing happens. The first thing is there's no error, so the script is working. If I press 5 here and zoom in here, oops. Anyways, there's no error, meaning that the code is fine. If there was an error here, for example, if I explicitly type error, you will see here that an error will appear. Of course, it is appearing. Error is not defined on line 14. And I can fix it. So there's no error, but there is nothing happening. But guess what happens if I get the z-axis and make it equals to 1? Check this out. Well, I'm moving forward. Great. And the camera collision, now we can already see that the camera collision is working. And you can also see that we did not even have to write any code to make this forward direction align the camera. This is because the third-person camera component is already doing this for us. Cave Engine does that because Cave Engine knows that this will be the case like most or all the time. So yeah. So now what I need to do is, instead of hard coding this, we want to use the keyboard inputs. Luckily for us, we already have the events here in Cave. So what you can do is a simple math. Let me actually make it simple first, and then I'll explain the math. I can do if events.active, which is the way for Cave to see if an event is, if a key is actually actively being pressed or not. And the event names in Cave is belongs to cave.event dot, and you have the key name here. For some reason it is not showing, probably because I'm not importing here. So I believe that if I import, yes, it will show all the keys. And of course, if you want to look up, you can just open the event here and you see all the key bindings here for you, for all the keys in your keyboard, even keys that I'm pretty sure that you don't know that existed. For example, keypad mem clear. I don't know what is this, but some keyboard probably have this. So all the key bindings, including for joysticks, are here. So if I'm pressing W key, I will make Z equals to 1. Of course, I'll make it 0 by default. And if I'm pressing the S key, I'll make the Z equals to -1. So if I play the game now, I'm idling. If I press W, I will go forward. And if I stop, I will stop. And if I press S, I will go backwards. Very simple. And there's a way to do this, a hack to do this faster in a game. That is basically getting Z equals to this condition minus this condition. It is exactly the same thing, except that this one uses math, and it's a bit, at least in my mind, it's easier to read than the other one. But I've showed you both, so you know, okay? And I'll duplicate this and do the exact same for the x-axis, except that it will be key A minus key D. And with this, I can go ahead, play the game, and you can see that I am already doing some cool stuff. One problem is that I'm moving faster in the diagonal than I would when I'm moving forward, backwards, and all that. So to fix this, this is why I've built this direction, by the way. I will see if I'm actually moving. In other words, if direction.length, which is the length of the vector, is greater than 0, it means that this is probably not 0. It's definitely not 0. In this case, I will do dir.normalize to normalize my vector, so I will move in the same speed in the diagonals. Okay, and there's one last thing that it's good to do here before we move to the part 2, which is to actually make the character itself execute the proper animation, which is to make this walk and run with different speeds. Okay, what I would do in a player controller is I will create here a variable. This is very good in Cave, called walk speed, and then run speed. Let's say that it walks at 2 meters per second and run speed is 6 meters per second. Okay, and the reason why I created this variable is that now if I go back to Cave Engine and select the player, if I go ahead here in my player controller, I'm just minimizing here, you can see in the overrides tab that now I have run speed and walk speed, and it does have these values that I've initially defined that. And what is good about this is I can create a different value, for example 11 in the walk speed, and this is specific to this component. Okay, so of course the player, I will only ever have one player, but if I have like a script for the enemies and I have 10 different types of enemies, I can have different health points for them, and then I can define it here, and this is very good for us to do some local changes here. So if that's the case, you can see that the number is 2 in the walk speed, but I've override, this is why it's called override, of course. I've changed this to be 11. I'll go back to 2 because I already know that 2 is good. Anyways, so we can do this. This is a new trick that you're learning, hopefully, to make your games. Anyways, what I will do now is I will check if I'm pressing Shift K. So I will do if events.active cave.event dot k left shift. So if I'm pressing Shift key, I will multiply this direction by the self.run speed, which is of course the variable that we have defined here. If I'm not, else I'll multiply this by the walk speed. So this will allow me to run. So I'm walking, and if I hold shift, it will go very fast. I'm probably gonna have to change this value very soon. But let's not worry about this now. Let me do one last thing, which is to jump, to make the character jump. This is very nice. What I will do here is if events.pressed. So this is a new one. What is the difference between active and pressed? The difference here is that active will return true every single frame or every time this specific button is being held or pressed. The pressed itself will only return true the moment that you pressed it. So if you press this for 10 seconds, this will only be true one time, which is the first frame that this is true. And by the way, yes, we have the released, which is only true as soon as you release the button, but immediately for one frame, okay? So make the space. If I'm pressing the space key, I'll actually jump. How to jump in Cave? Self.character.jump. How hard it is, right? The character does everything for us. By the way, if I jump here, it will probably be very bad. You can see it is very high, not good. So what I can do is get the player, go to the character component, physics settings, and I can adjust here the jump speed, the gravity, and all that, the fall speed, until it's like, until I like. For example, now I like. With 5 meters per second of jump speed, I like, it's good. Great. So let's keep going here. The part 1 is complete. I don't know if you've ever noticed that, but yes, it's complete here. Can jump, and all that. Can walk, run. Of course, we need to adjust the run speed and the walk speed, but it is complete, and I can even have the camera collision. Now we need to make the character, well, execute the proper animations. And this is split into 2 different parts, actually. The first part is to make this character look at the direction that it is currently moving, because as you can see here, well, it is not. It is moving sideways. So let's do this first. For this, I will need to get the proto mesh. And this is actually why we are creating this hierarchy here, having the player and the proto mesh as a child. Because if this was a single object, we were not going to have, we were not going to be able to do this that we are doing here this easily. It will be a nightmare. It will be very hard, very annoying to do the same thing. So this is a common technique in video games to have like this parent and child object here, just to allow this to be easier. So what I'll do is I'll right click and I'll click here, Shift A to select everything, and I'll Control C to copy the name of this mesh. And I'll go to my script in the start method, and I'll create a mesh variable. And this mesh will be self_entity.getChild. The get child of the entity, as the name suggests, will return a child entity of this entity itself. And this is also recursive by default, as you can see here in the parameters. The first parameter is the name of the child. Recursive, it will search child of childs of childs. So I will open this and I'll Control V to copy the name of my mesh. Great. And then I'll get the transform of this mesh. Guilherme, what is the transform? The transform, so this is the mesh that we get. The transform is this component here. Transform. Very nice. And a little trick. There are 2 ways to get the transform. The first one you already know, which is exactly the way we did here with the character component. We can do self.entity.get transform. And of course we can hint to Python, because the get will return like a regular component. So Python, the Visual Studio code, will not going to be able to provide hints, but you can do transform component. So this is one way to do. But in Cave, we already know that you will be using the component, the transform component a lot. So there's an optimization here, and this is actually faster when it comes to performance, by the way, to immediately get the component of an entity, which is equal this to self.mesh, which is this mesh, dot get transform. And in this case, it will be faster, and we don't even need to hint to Python, because as you can see here, if you mouse over, it already knows that it returns the transform component. Because again, this is faster, this is specialized, a specialized function only for the transform, so this is very good, and we don't need to worry about it. Nice. So with this in hand, let's actually go ahead here. I will probably do this here, because if the direction is not is greater than 0, of course, it means that the character is moving. So if it is moving, I will make sure to align this mesh transform to this direction. In Cave, it's actually very simple. Look at, it takes a direction. In this case, it's direction. It takes an up vector and all that. I'm not going to do anything like that. It's fine. And by the way, just because how it works, I will negate this direction. So I want to look at the opposite direction, okay? And you will see that this will be correct. If you don't negate this, it will look at the wrong direction. You can test and see why. But as you can see, if I move in the character, it is indeed moving to the right direction. But there's a problem, many problems actually. The very first one is that, well, it is changing the direction, and in this case here it is correct, but if I rotate the camera, it will no longer follow the right direction, because the direction here is local. So we actually need to be a bit smarter here. We need a global direction, okay? And then what I would do, I said that I wanted to do this here, but I will do it before here. I'll get the direction again. I'll actually copy and I'll actually paste this. The difference is that the direction here will be self.character.get walk direction. And you may look at me and say, well, this makes no sense, because we're setting the walk direction and then we're getting, so theoretically the direction will be the same. And of course there's a delta time multiplication, but this multiplication is not changing the direction of the vector. So what is going on here, Guilherme, you may ask? Well, it's all because of this default parameter here in the set walk direction that Python is showing, local equals to true. So local equals to true allows the direction to be local, as we just saw, but it will internally make it global. And if I get it back here with the get walk direction, it will return this globally. So the value will be a global direction, not local. So this is why we are doing this. And if I animate, now if I'm rotating, it will always look at the correct direction. Very good. The other problem is that it is very thick, it's very rough, the change of the direction, so it will be good to slowly interpolate between these. And yes, this is correct, and this is actually very easy. You just need to type smooth here. And then it's another function that takes a parameter of the lerping amount. And I'll put 0.2, for example, and it will be good for us to lerp this direction smoothly. So if I play, you can see it is no longer abruptly changing the direction. Very nice, very nice. So now there's one last thing that we need to do. We are almost there, almost there. Very nice. What is the last thing that we need to do? Well, we actually need to execute the animation, the proper animation, because it is not executing, as you can see. So how to do this? We will need to get one last component, which is the animation component. Because of course, what we are doing, what we need to do in the code is to basically change the animation here from the idle to, for example, the walk animation, or the run animation, or the fall animation if I'm jumping, or the idle if I'm not doing anything. So we need to get from the proto mesh the animation component. So let's do this real quick. I'll do this in the start. And I like to call the animation component an animator, just because it's a cool name. And it makes more sense than animation. Anyways, probably the name of the component itself should be animator. I don't know, but it's already animator, animation. And I'll type a hint here. Just for us, this is a Python hint. This is just, again, for the IDE to give us the autocomplete. Because we'll need to use the get method. Not the entity, but the mesh, because the mesh is the proto mesh. Animation, which is, of course, animation component. I'm omitting the component. So with this animator, we can very easily execute different animations. Nice. Let's do this. The first thing is, if I'm not on ground, I want to execute the fall animation. Right? Actually, let me keep it simple. I will start with the movement, and it will be easier, right? If this direction length, I'll actually use this one because we have it here. Let's move this to appropriate is running. I'm just trying to think about how can we save some repetitive code here. Okay, so this is good. And also, maybe we can have is moving. Because this will be very handy for us when animating, because of course, if this is moving, then I want to execute an animation. If I'm running, then run animation. Otherwise, walk animation. If I'm not moving, idle animation. So does this make sense for you? Probably. So if I'm moving, I'm either running or walking, so I'm checking this here. And if I'm not moving, I'm idling. Very simple, right? I can also expand this to see if I'm on ground. There's this very handy function here to check if the character is on ground. If I am on ground, then execute all this. Otherwise, well, fall animation, because I'm not on ground. Great. So now what do we have to do here is to replace these comments with the actual execution of the animation. How to do this, Guilherme? Well, very simple. Let's start with the run. Self.animator, which is the animator that we gathered before, dot play by name. So it plays animation by its name. And what is the name of the run animation? Well, we can go back here and check. I know the name already, but I'll double click here. Remember, run, right click, I'll click here, Control A to select everything, Control C, and then I'll go ahead and paste it. I'm saying for you to Control A and Control C because I've seen some people that say, well, this is not working, Guilherme, and then after 3 hours debugging, this person put like 3 white spaces here after the end. So see, it sounds like the same name, but there's a white space here. So not good, not good. So this is why I'm saying if you're getting started, just Control C and Control V, it's fine. It takes other parameters. They are all default, they're all optional, but I want to change. For example, the blend between the two animations. So if I'm not running and I start run, what is the blend? And it's 0 by default, I'll put 0.2, and this is in seconds, okay? So 0.2 blend. And I also want to define this animation to loop, because it's default here to false. As you can see, it doesn't loop. So loop equals to true. And this is how to do this. And I'll actually copy the same code here for the walk. Again, go ahead and check the walk, the fall, and the idle animation name here. And I'll just speed up things, and I'm not going to do this because I already know and I am sure about the name that I've added. Good. So, and for the fall, I'll actually make a little bit of blend, a little bit more, because I figured that this is good. And anyways, so this is how to actually animate the character in Cave. So let's test this. Let's actually play the game. And you can see it is walking, it is running, it is falling, and it is idling. So very simple. We have a complete character moving, walking, running, and idling. Great, how cool is that, right? Let's actually continue a little bit and then explore some other stuff in Cave, because now we finished the logic. We finished the most of what I wanted to show you in this video in particular, which is how to get started. Oops, we imported a bunch of events here. And I want to make this scene a little bit cooler because it's boring at the moment. Very, very boring. So how to make this better? How to make this cooler? Other than changing the shadow bias to hopefully reduce a bit of the pattern panning. I am improving the shadows, by the way, so this will probably be gone in the next version of the Cave. Let's actually get some textures here because I want to show you how to import textures and all that. And for this, I recommend a website called Polyheaven. The link is this one. You can literally type polyheaven.com and it will work here in your computer. This website is very good because most textures here are CC0, meaning that they are public domain, and you can simply download and use in your projects very easily. And it does have ADRIs for sky boxes, you have models and textures. So we'll do a bit of all of this in this video. Okay, so let's start with the ADRI to define a sky for the game because it's very boring at the moment, right? I want to do a better sky. And let's go to Polyheaven. I will middle click here to open the ADRI Heaven. And I'll actually try to find a good one. Oh, I really like this one. I also like this and this. Oops, this is a spoiler. Let's try this one because I like the sun here. Very important, you need to open the HDR, Jesus Christ. This order format is not supported by Cave, but this is. And I'll click here to download. It's 26 megabytes, very heavy, it's not lightweight, so make sure you know you don't have hundreds of HDRI in your project because this is not going to be good. And let's actually go ahead here and drag and drop this texture to this. By the way, it is, I do have, let me try to show you the texture here. I'm just dragging and dropping. So this is the ADRI. I'll click here, left click the background, and I'll go to sky here. And I'll expand the sky color and I'll drag and drop this texture to it. Whoa, nice, very nice. Let's actually rotate the sun to match this. I can also rotate the sky, by the way, but I'll do this with this sun. Good, it's matching a little bit better now. And I believe it's a bit late in the day, a bit bright. And also the ambient color, I will actually drag and drop the same texture to this to give an ambient look to it. So save and run. It is already looking good. So part one is complete. Great. By the way, if you don't like the, let's rename this to Skybox. So I click here. If you don't find like the resolution, because you can see size and format is 32 megabytes, what you can do is go to image compression and compress this using the DXT. Let me just save the project before. I will compress. Boom, it's now 8 megabytes. So it's much more lightweight than 32 megabytes, and the texture is the same. So this is very handy, right? Very, very handy. Okay, so now we have this cool ADRI. I believe that I'll go with it. I'll not even try the others. Or maybe I will try the others. Just because I'm weird today, let's try this one. I already have it downloaded, so. Yeah, the other was better. Anyways, let me go back here. And I'll delete this. By the way, when you set an ambient color here, it will actually also work. Let me shift A, add a mesh. I will delete the static body and I will change the mesh to the default sphere. And I'll right click and create a new asset material, drag and drop to this sphere. And I'll reduce the roughness and make it metal. You can see here that it is using this as the reflection for this. So this is very good to know. Definitely good. Yeah. Anyways, I just wanted to show you this. Now let's continue here, and we already know how to import ADR and configure this. Let me actually, I'll let the textures. I want to import these two assets here, but I'll get there. Let's go to the textures now in the polyheaven, and then let's pick one texture from the ground because this ground is annoyingly simple. I want this to be cooler. It's not good here. Let me actually create a new folder here. Materials. Let me actually dissolve this. I will create a new folder called assets. And I'll move the, let me put this metal test. And I'll move this to the assets. Good. So inside here, we'll be able to play around. So now let's try to find a ground texture to this. I don't know which one would be a good ground texture. Maybe this. I want to find some moss, to be honest. Let's search for moss. I like this and this. Let's try this one. So I don't want 4K texture in this case. I want 1K. It will be enough. Oh, it's a blend file. I'll click here to download the individual textures. Instead, it will be easier. And then I will just download the diffuse texture in PNG. This is not what I was expecting, but anyways. The normal. And probably the rough map. Roughness. I right click and save as image. Now do the same thing with the other textures. And let's go back here. I create a folder called textures. And I'll drag and drop my 3 textures. And one way to create a material for them, there's 2 ways. The first one is right click, new asset, material, and all that. Or we can simply get the texture and drag and drop to the object and it will create a material for it. And then I can put rocks. Good. And I'll move this material to the assets folder so I can have the rocks here. And I'll click here to edit and I'll finish the settings. Because as you can see here, it is not looking very realistic at the moment. First thing I'll do is to go here in the UV scale and I'll change this to probably 4. so it repeats a little bit. Maybe 3 or even 2, because I believe this is a huge material, huge texture. I'll put 2.5. Okay, and then I'll go ahead here in the normal map and I'll get the rock normal map. It is already looking better, way better actually. And I will do the same thing with the roughness. Then I can adjust the metallic as I want. Well, now we have a ground. Great. I'm finding the background a bit too dark. So let me adjust this a little bit. Yeah, it's a bit better. And let me make the sun more bright. Yes, nice. And maybe more intense, the color of it. Okay, so this is better. Perfect. Now we have a ground texture here. Good. What I would do is, so now we have this. Cool. And I will finally move to the other part, because otherwise we'll be here for... Can I actually texture this cube here? Just for fun. Let's see how many time we have. Let's put a brick wall, and if it's a very bad brick wall, I will apologize and cry in the corner, and it'll be good. Okay? So let's do the diffuse, the normal map, and the roughness. Yeah, I'm pretty sure that this will be very bad. But let's try. Let's try. I'll save the textures. And then I'll go to the textures folder, get my downloads. By the way, they're here. And I'll drag and drop this to this. Cool. And I'll drag and drop this to create a material. Call it brick. I'll move to the assets. And with my brick selected, I go ahead and drag and drop the normal map and probably the roughness. It sounds like the normal map is flipped, by the way. Let's try the DirectX normal map, even though this is clearly wrong, because cave is clearly not DirectX, but let's try it. Maybe it's a fix that I need to do in my material settings to flip the normals. Yeah, now it is no longer flipped. Huh. Interesting, and living and learning. I believe my normal maps are wrong. Good. And this means probably that... oh, I forgot the moss. No, I don't remember. Is this right? Oh no, I put this accidentally in Afrikaner. Where's English? Okay. DirectX normal maps. Let's try. Living and learning. Live session debugging here for the engine. Let's try this one. I'm actually very bad looking at normal maps. I don't think this is wrong. I think this is correct. Maybe. Yeah. Anyways, let me know in the comments if it is correct or wrong. But what I know is now we are getting there. We're having some progress here, which is very exciting. Very nice. So let's go ahead and import some meshes here. I want to have meshes for us to finish this video. So You probably already know which meshes that I will import, but I'll pretend that you don't and say, well, if you go to Polyheaven and click models, whoa, you'll find models. One thing to keep in mind, you have a lot of vegetations in models, but Polyheaven is not particularly game ready. So most of this is for movie. It's not for game. And what does it mean? It means that they have trillions of vertices. So this is not good, not good at all. Okay, for example, if I open this vegetation here, looks very realistic, but this is the wireframe. Not good. It does have 695,000 triangles, so this is not good. Like, you can make an entire game using this amount of triangles. So this is good for a render, not for a game. So you have to know this. Don't download this and put into Cave, because it will explode the same way that it will probably explode if you put this in Unity, Godot, or whatever. It will explode. Don't do this. But we also have some others here that are good, that are decent. Then I have two here that I recommend, which is this one. And I'm actually downloading this now. There's a lot of triangles. You can see 28K. I believe this is very high resolution for this. But well, it is. We can try. And we also have these rocks. Again, 63K triangles, which is crazy high for these rocks. But I'll explain to you why I'm downloading this. Let's start with the rock. And I'll download here. Actually, I already have this downloaded. I'm download this again. Not gonna be the end of the world. So it's when you download this, let me actually create a folder here just to show you. When you download this, it will have the zip file, and I'll right click and extract here everything from the zip file, and you have the FBX and the textures. Cave does not support X on this format here, so we're gonna have to convert this into PNG or wherever. It's actually not hard to do this. If you Google, you have like countless websites that you can convert. Let's try this one. Where's PNG? Now convert here. Queued, running, and why it does download? Good. 5 megabytes, it's a lot. But now we have the texture. So what I will do is I will go ahead and import this. Of course I will do this. I'll import those 3 textures here, as you can see. And I'll go ahead, select this, and I'll drag and drop to the assets, not to the textures, of course. So you already know this. I'll click here to create a folder. I'm not gonna click here to import the template. We have one material, rock moss, and I'll call all this rock 01, rock 02, 03, 04, 05, 06. Okay, good. So I have this. I'll click import. And it even have like the textures here already. Not all of them. So I need to put the roughness and I also need to put the normal map. Good. And now if I drag and drop one of these rocks to this, to the world, you can see the rock is already here. But there's no physics in it. Where's the rock? Here we go. It's here. I can go ahead and go through this. So let's try to actually make a physics, make some physics for this rock. Okay. If you press 8 to see the wireframe, you see that this is very high resolution. Not good. Definitely not good for rocks. So what can we do to optimize this? What can you do to make this better? By the way, I will just do this for one rock. I'm not going to do this for all the 6 rocks because we have limited time here, but the process will be the same. Okay. The first thing is I'll promote this to a template. Okay. So what I can do is to click here in the rock, right click here, promote to template. So now we can see the rock is green, and I can no longer see its settings here. I can no longer see anything, and you can see it is green, of course. The advantage of this is that I can create different copies of the rock, and they will all point to the same rock. What rock, you may ask? Well, this one here that is now green, which is a template. And what is the advantage here? I can double click this and I'll be able to edit this rock individually. Let me actually press Alt W to reset the position. And if I do any change to this rock, for example, if I change the color here, the tint of my material, and if I click here to go back to the scene, you can see all the rocks are now red because the template is red. So this is template in Cave. And we'll do this in particular, not to make the rock red, but to make it easier for us to edit the shape, the physics of it. And I can, of course, click here and create rigid body from mesh. And it will create rigid body component. And you can see that it does have thousands of triangles. It's a very high resolution rigid body. But of course, if all we want is a lazy way to fix the physics problem and we don't mind having zero performance, well, it will work. You can see the character can walk on top of this rock. Very good, right? But of course, we want to be smart here. We don't want to be dumb. So what is the smartest way to do this? Well, I will actually get this rock. So this is the rock 2. You can see the name of the rock. Oops, the name of the rock here. And with this rock, let me save this. I will right click and duplicate this rock. So we have rock 2 copy, and I'll rename this rock 2 physics. Why? Now I have 2 meshes that are the same. And if I select here the rock 2 and go ahead, let me actually delete this. No, let me actually do this first. I get the rock physics. You can see that it does have 2,700 vertices and 15,000 triangles, which is a lot. And I'll go to operations, mesh decimation, and I'll decimate this to make a very low resolution, low poly rock. So you can see 256. I'll click here to decimate. You can see if I drag and drop this rock here, it is pretty much the same rock, except that this copy does have the UV messed up and all that, but the shape is the same. And why does matter? Well, check this out. I have this mesh, very high resolution. Let's change the mesh here of the static body to the decimated mesh. Boom. Now I have the same shape, but much less vertices, which is much cooler. It's much better for us. Okay. So if I go back to my scene and press 3, you can see that the physics is much more lightweight. And I can still walk on the rocks, but it will no longer explode the performance, which is very good. Very good, actually. One last thing that I want to do with this rock. Let's try to see if I have 4K textures for it, for the diffuse. Because I figured that this texture here is very low resolution. You can see it, right? Like if I go nearby, it is terrible. It is disgusting. So let's try 4K. Where's the rock? Apparently there's no difference between the 1K and the 4K, which is kind of very funny. Meaning that the only difference here, that this is probably upscaled. Funny, very funny. So this is a 4K texture, but it is probably upscaled. Yes, it looks terrible in 4K. So it's not the engine's fault. It is terrible in all the ways. Let me go back to 1K and I'll delete this 4K because it weighs a lot. But you get the point here, you get the story, right? Oh, no, actually, I changed the wrong thing. Import this again. It's not the rocks. Huh. I'm glad you guys are seeing this live, right? Yeah, now it's better. Yeah, it is definitely better. Good. So at least the diffuse is better now. Save the project, press play. Yeah, my rocks are much better, much more crisper than it was before. Okay, so just to finalize this video, I want to import, because I'm curious, this last thing here, which is this fort. Let's try to do this. Let's try. It's 44 megabytes. I already have this downloaded, if I'm not mistaken. So let me extract it real quick here. There's a lot of textures here for the fort. I'll actually create a subfolder here in my textures for the fort. And inside of it, I'll drag and drop all the textures for this. Good. And then in the asset, of course, I will drag and drop the fort itself. Create subfolder. I want to create a template. There's 45 meshes, 3 materials, import. Let's go. Unfortunately, the textures here are not linked, which is annoying. So I have to probably think about the textures by hand. So modular fort one wall. Oh, the name are very easy here to understand. Okay. Rough and normal map. So good. This is the first one. The second one is the trim. So if I type trim, I believe that it will work. Yeah, very good. And the last one is the plaster. Diffuse and the plaster roughness. Good. And probably if I reload, let me save the project. If I go ahead and reload thumbnails, it will be all textured. And the entity template, see, this is what I meant. It will create for me the textures. Oops, the rotation here is very wrong. It's not happy with me here, messing around with it. So you can see here that we do have this modular. I want to, I will oops, the rotation here is really weird. But of course, I want to do the same process that I did with my rock to adjust the physics and all that. But I'm not going to do this in this video because it would be too big. But I really want to import this, at least the tower, to the world, so we can see how the tower will look like, and maybe this. So what I will do is I'll click here the tower. I right click and click copy to clipboard, and then I'll go back to my scene. Let's create a folder here called fort. Just organize. Right click, add children, paste from clipboard. And it should be somewhere here. Let me reset the scale by Alt R. You can see Alt A to reset the rotation. 90 degrees. I will reduce the scale a lot. And you can see that I have the fort walls. Great. Let's actually go ahead and copy one more thing, which is the, let's see which one we want to copy. Large one or the small one? Let me copy this one. Copy to clipboard. I'll go back to my scene in the fort, right click, add children, paste from clipboard. It is not here. I will just press G to move it here. And I'll press Alt R to reset the rotation. I'll scale it down a little bit. And remember, before you crazy duplicate everything, let's right click, asset settings, a group assets. I will dissolve the entity folder, and I'll promote this to a template. Let me just rename fort power 01, and I'll promote to template, and I'll do this fourth wall 01, and I'll promote to template. So now I have two templates here that I can easily later on open here and edit as I want. Very good. This is what we basically want. And of course, now we can try to build something. For example, this template here. Oops, the rotation is really upset here. Once again. Interesting, the rotation is not liking my approaches here. Doesn't matter. Let me just 90 degrees this. Move it somewhere to the center. This will be enough. I'll go back. Oh, I forgot. The transform of the root will be overwritten all the time. So this is important to know. And good, I have here rock walls. Very nice, very nice. And of course I have this with physics. I don't have physics in these walls, but you know how to add the physics to it already. And you can also even create a low poly, a low resolution shape to add physics to this, and it will work just fine as well. Folks, this is pretty much it. This is an introduction to the game, to Cave Engine. It was a long video, but I believe it was necessary, very necessary for you to get started, because this is literally your first time using Cave, and I hope that you learned something cool here and you are ready to make some games using it, because I can't wait to see what the community will be able to do with Cave Engine, and this is why I made this long introduction video. That is also very necessary once again, right? Oh, don't forget that you can export your game. Very easy. Go to settings, export your game. You select the main scene, click here to export to Windows, and that's it. It's very easy. Actually, let me do this live just to show the Cave is no joke. Here you go. You have your game. You can zip this and send to people, and it will work. Double click it. You load the project. Here you go. You have the game working, and this is exported. If you press F11, it will go full screen, and this is your game. That's it. Oh, very nice. Let me actually take the screenshot here for the thumbnail. Here you go. Folks, that's it for this video. I hope you enjoyed. Remember that you can purchase the engine on itch.io all this year 2024. It is with 40% off because it's a launch discount for Cave 1.1.0, or you can become a patron and also get access to the engine. And I can't wait to see what you'll be able to do with this engine. Thanks for watching. I'm very happy to be here to be recording this video. This is very nice. This is like a dream coming into reality. And join the Discord, share everything. Let me know if you have anything else, any questions or comment, and I see you in the next video. Bye.